Okay, question 6. Clearly a wave function. You don't even have to read it, you can just take it in, just tell it's a wave function question because we're combining cos and sine waves into just one wave in this form or wave function form. If they don't tell you which form, you pick one. But yeah, let's go ahead then. So we've got k cos x plus alpha. So if we look at the front of our exam booklet, we'll see the addition formulae, and that'll tell us the cos AB expansion. So don't lose marks on that. Make sure you get that nice and tight. So that's going to be k. Now when it's the cos's, it's cos and cos, like a wee space, and the sign changes in the middle, and then it's sine and sine. And it is AB AB, so it's going to be x alpha x alpha. So just however it works for you, that's how I write out. But don't make a mistake with that. If you want, write it out with the AB first and then substitute it in. So that's about that. The next thing I'm going to do is I'm just going to move the alphas to the front of my equation. So I'm going to say that I've got k, sort of changed colour for no reason there, k cos alpha, cos x, take away k sine alpha, sine x. All I've done is I've just moved that to the front of the equation so that I can do this next step. So now I'm going to write the question out. I'll do that in red actually. So I've got 2 cos x, take away 3 sine x. So what I was saying was this function can be expressed in this form. So I'm saying that this is the same as this. So if that's the case, it holds that this has to be equal to 2. Because look, cos x and cos x, got a negative and a negative, sin x and sin x, so then this has to be equal to 3. And at this point, we're going to explicitly state that first of all. So I'm just going to say that. Well, I'll put the heading actually. So now we're going to work out our k value. So this was my little expansion to get me started, and now I'm going to do my k. So I'm going to say that k sine alpha is equal to 3, and k cos alpha is equal to 2. So if I was to do k sine alpha divided by k cos alpha, the k's would cancel out and I'd be left with tan alpha. So that's equal to the sine over cos. So then alpha is the inverse tan of 3 over 2. And actually, sorry, I should have taken the heading there. Alpha. Not k. I got a bit carried away and started to do my alphas there. It would be 3 over 2. So let's do that. Let's check my calculators in degrees. That's fine. Does this question in degrees? Yes. Yeah, so just double check that. Shift tan 3 over 2. So 56.3 degrees. And I'm just going to check which quadrant I should be in. So my sine is positive. So if sine's positive, it's there. Cos is positive, so it's there. And the tan comes out as positive, so yeah. We're in the first quadrant, so that answer is acceptable. Very good. Next thing we'll do is we'll work out the k. I got so excited I just worked out alpha for some reason. So k is really just Pythagoras. We're doing 3 squared plus 2 squared square root. Okay. So these values here, square, square, square root. Simple as that. So that's root 9 and 4, so that's root 13. And I'll just leave it like that, I think. That's okay. And let's just write the final answer out. So it was a x plus alpha. So the final answer. So I've got root 13, not root 13 equals, sorry. Root 13 cos of x plus 56.3 degrees. That is a rewrite of these two functions combined. Now, if you want to go to Desmos and draw those out, and you'll see, but it's pretty cool actually. If you add together a cos and a sine wave, you just end up with another wave. And again, is it a cos or a sine wave? Doesn't really matter. You could rewrite this any way you like because cos and sine are the same thing. They're just out of phase. Hence, this value here. It doesn't. Depending on what you use, this value will change. And the k is the kind of relative height, which is not 2 plus 3. It's kind of like a Pythagoras deal. So yeah, that's us got our wave function written out. Fantastic. And the next bit says, hence solve that. Solve when this function here is equal to 3. Okay. So the first thing I would do for that, if I could zoom in, 2 cos x take away 3 sin x. So 2 cos x take away 3 sin x. First thing I'd do is say, well, we've just proven that that is equal to my wave function, which is root 13 cos x plus 56.3. And we're trying to solve for when is that equal to 3. So if I want to solve when that's equal to 3, I'll say, well, where is my function, my wave function, equal to 3? There you go, just put it equal to 3. If it asks for the max and the min, the max and the min is the root 13 negative root 13 FYI. And then we're just rearranging, aren't we? So we're saying, well, 3 over root 13, and I'll do cos inverse is equal to x plus 56.3. So all I've done is divide by the root 13, shift cos. So what does that give me then? So 3 over root 13, inverse cos, shift cos. That's going to give me 33 point, I'll call it 7 degrees. And then it's just a standard trig solve. We have to say which quadrant are we in. So I was looking for when it's 3 over 13. I was looking for when cos is positive. This value in here, positive, yeah? So cos is positive here and here. So I've already got my quadrant 1 answer, which is going to be 33.7 is equal to x plus 56.3. Fantastic. And my quadrant 4 answer will be 360 take away 33.7 is equal to x plus 56.3. There we go. So let's get our calculator out. Let me pause and I'll move that down just a touch. There we go, tidier. So 33.7, I'm going to take away 56.3. So I've got x here is negative 22.6, and over here I've got 360 take away 33.7. And I'm going to take away 56.3. So that comes out as 270 degrees. Now the limits for this were between 0 and 360, okay? So I like this answer. This is looking good. And I'll be thinking, well, what's the period of my wave? It's just 360, isn't it? So if I add on 360 to these numbers, or indeed take away 360, that gives me all the solutions, you know, infinite in both directions. So what I'm going to do is I'm going to add on 360 to this one to give me an answer which is in the range I'm looking for. 360 take away 22.6, that's going to give me 337.4. So just you're making sure that you're in the right range for these things, and yeah, it's very easy to just make a little mistake at the end there. So you're making sure you're in that window. This one was in the window, this one wasn't, but yeah, now it is. So just watch out for that at the end. Sometimes the wave function you'll end up just a wee bit just missing that window, and all you need to do is just add the period or take the period away, and you'll be fine. All right, so wave function, really good question to get done, get under your belt. It's very prescriptive. You know, that really is just autopilot. You know, doing your expansion, doing the alpha, doing the k, final answer. So you know, not a lot changes here. And then this one as well with the solve, that is just basic trig you're solving, doing that since National 5. It's just kind of asked in a slightly different way, isn't it? And also it might ask you about the max and the min. This is the max, the negative, this is the min. You know, but that is actually just standard trig. So look at that, a nice little 7 marks for, you know, not any problem solving, just following the recipe. Okay. So I hope that was helpful.